The familiar gadgets of everyday life. They get faster, slicker, and slimmer. But an amazing new material, discovered by British scientists, will transform this technology forever. It will allow us to slim it all down to the thickness of a piece of paper. It's called graphene. Even under the microscope, it doesn't look much, but it won a Nobel Prize for the two scientists who discovered it, and it's been lauded as the miracle material of the 21st century. It's stronger than diamond, more conductive than copper, more flexible than rubber, and it's so thin you can barely see it with the naked eye. Graphene is made from the stuff in your pencil, graphite. And graphite is millions of microscopic layers of tightly packed carbon. When I put my thumb into the graphite, give it a rub around, it gets covered in a layer of it. If I then press that back onto the paper, millions of layers are peeled off. If I keep smudging my thumb across the paper, these layers of graphite get thinner and thinner. And if I keep going, eventually I'll end up with a layer of graphite 1 atom thin, and at that point I've got graphene. Material scientist Dr. Aravind Vijay Aragavan works with the team who discovered it.
This is graphene at about 20 million times magnification, and you can see the individual carbon atoms, which are the white dots you see here, and each carbon atom is connected to 3 other carbon atoms. Now the carbon-carbon bond is so strong that actually makes graphene 200 times stronger than steel.
To demonstrate graphene's properties, Aravind dissolves graphite, the stuff from your pencil, in a solvent, then injects it into a special printer cartridge. This sprays a thin layer of graphene onto a cellophane backing, which holds the thin graphene layer together.
What we have here then is cellophane coated with a layer of graphene.
You sure?
Yes.
Because it just looks like a piece of cellophane to me. On its own, cellophane cannot conduct electricity, but when graphene is added, something remarkable happens.
And we have an LED
bulb there.
lamp there, and as soon as you wire it up, the lamp starts to glow, so which means that there is current flowing through a piece of plastic.
As graphene is so thin, there is very little electrical resistance, making it the most conductive material ever created, allowing scientists to shrink our circuit boards, leading to smaller phones and computers. But graphene has another key property: flexibility.
You can essentially pick it up and you can bend it and you can twist it, and still the current flows through it and the lamp stays on.
That is really quite incredible. This flexibility is getting electronics giants excited. Prototype animations show graphene applied to super thin bendy plastics, making phones and tablets foldable. So this is really revolutionary. This is going to change things, isn't it?
Yes.
Graphene's thinness also means it's 97% transparent, tackling a problem we face with touchscreen technology. Today's mobile phones contain an element called indium in the touch screens to make them work. It's rare and becoming more expensive, and the coating that it makes is brittle and inflexible. On the other hand, super bendy, conductive and transparent graphene is made from carbon, the 6th most abundant element in the universe. But high-quality graphene is currently hard to manufacture on a large scale. Any imperfections in the process dramatically reduces its conductivity. If scientists can crack this problem, it won't just be consumer technology that will change. Electric car batteries built from millions of layers of graphene will charge in minutes thanks to its high conductivity. Microscopic graphene sensors inside our body could detect harmful microbes, responding to tiny changes in conductivity produced by individual bacteria cells. Graphene may well be the biggest technological revolution since the silicon chip.